Hello, my name is Jacob Weikert. I'm partner with Tristan Stevens, and this will be for program assignment 3. I will be going over IP segmentation portions, and Tristan will go over the router forwarding portion. To begin, we are tasked with taking an 80 character string or more and splitting it up into 2 packets. To do this, we just split the packet in half and send it with UDT send. You can see our message was here, and then here's the print statement for the output. Hello, I'm testing a character string. You can see it didn't send all the way because the maximum transmission unit is 50, which is just the capacity of data the link can send. And that has to include the header every time. But we don't have a header in this case, but we'll see it in the next problem statement. But we can see here that the host 1 sends the segmented data to router A, and then router A forwards that data onto host 2, and host 2 receives the data, the 2 packets. You can see now we'll take a look at problem statement 2, which was us implementing this functionality, where between the router and host 2 we'll have a 30 MTU. To do this, we had to edit the network packet class. You can see we're in network 2 now. We had to add a flag and an offset, and the offset will just keep order of where the segments belong, and then the flag will tell us if it's a segment or the last bit of a segment. 1 if it is a segment, 0 if it's the last one. The offset will be where the fragment is in the datagram. We also had to edit our host class to allow this, the UDT send, UDT receive, so our send will segment the data based on the MTU, and then the receive will take that data back and put it back together based on the offset and the flag. We have our router here. We had to edit the forward method to allow for segmentation as well based on the MTU between router A and host 2. So let's see this in action. Let's run this here, simulation 2. And we can see at first between our host 1 and our router, we're using a 50 MTU, which is what we set it to via the link file, and 30 MTU for the other. Sorry, it was via the simulation file here, so 30 and 50. So we from the router A to the server, and then router A will be 50. Going back to analyzing our data for the network, we will send the packet. We can see that we only get 50 characters, including the header for the maximum transfer unit. The header has the offset and flag associated with it. And then I got rid of the link print statements as I felt they were unneeded, but we have host 1 sending our packet, and then our router A forwards that packet to host 2. We can see that our host 2 receives all the packets from the segmentation. I'll hand it over to Tristan now for router forwarding.
Hi, I'm Tristan Stevens. I'm in charge of Part 3 for the data plane programming assignment. In Part 3, we have to create a routing table to route data through multiple routers from a host to another host. To do that, in my simulation 3, I added objects for routers and hosts, and then I added the paths from each node to the next, and then started a thread with each one of these routers and hosts, and then I sent data 1 and data 2 from host 1 to host 3 and from host 2 to host 4 respectively. In the networking file, I have code to handle the forwarding from one node to the next. So let's see what the output is. As you can see here, our data 1 from host 1 goes from host 1 to router A, then from router A to router B, from router B to router D, and then from D to host 3, as it should. For our data 2, it's routed from host 2 to router A, router A1 to C, from C to D, and then from D to host 4. So everything's working as it should, and that's data plane part 3.